myself, so I guess I'm audible. First of all, it's almost end of the day, so thank you for being here. It's nice to have at least 75% of the room. So, as introduced, I'm a staff engineer in data science at Kenvue. In case if you're wondering what Kenvue is all about, what Kenvue does, or if you're hearing for the first time. So we are a consumer health company. We have a lot of iconic brands. Some of you might be actually our consumers. We have brands like Aveeno, Neutrogena, Band-Aid, Stay Free, Zyrtec, Benadryl, so many brands, right, and many more. Have one of you used them? Any of them before? It's awesome to have some consumers also. I hope they get more and more after this talk. So, so today I'm going to talk about two fundamental problems. One is on-shelf availability and the other one is phantom inventory. These are very common, but at the same time very challenging to solve. They're very common problem in retail. So I'm going to describe what they are actually, and I'll also talk about the AI system that we have built in order to address these problems. Also, we'll walk a bit through the methodology, and I'll also share some results towards the end. How many of you have been to a store thinking that you'll purchase a product, but only to see that the product doesn't exist on the shelf? It's not so uncommon, right? It's quite common. So, being a manufacturer of these products, right, we care for our products, we care for our consumers. So, it could be frustrating for a consumer to find the product not being on the shelf, right? One time, probably it's fine. If that keeps happening in a repeated way, we may end up losing the customer. Now, it not only creates customer dissatisfaction, the brand loyalty the customer might have, but also, ideally, we could have gotten that sale on the day when the customer visited the store, right? So, because the product is not there on the shelf, we probably have unnecessarily lost the sales. Now, this is a very common problem, and we want to address this problem. Now, you can see a picture here. So, Dr. Shilabo is a skincare product that we have. And the customer, if they don't find it on the shelf, they may end up purchasing a competitor product, or they may stop even using this product, right? Now, on-shelf availability, as it sounds very, as the term sounds, it's very intuitive, ensuring that the product is always on the shelf whenever the customer is intending to buy it. Now, one thing I just want to highlight here, I have worked for other retailers as well in the past. But we are sitting on the manufacturer side. Kenvue is a manufacturer, so we supply these products. I worked for Walmart, Lowe's, such retailers in the past. So we don't have direct access to these, stores, right? So we are selling these products through several retailers. I think if you just go around here, if you may find Health and Glow or some other store nearby where you will find our products. Now, our goal is to, at this point, actually, if you talk about today, with this solution, we are live in more than 15,000 stores across North America. We are live in US, we are live in Canada. So which means this solution that we need to build has to be very, very scalable solution. Also, we are talking about more than 1,500 SKUs, right? Now, as I was saying, we are the manufacturer. We are not the retailer. Now, some retailers sell the items so fast. Some products get sold so fast. Some items might be high frequent, some items might get sold with low frequency, right? So the data granularity varies across the retailers, and we need to obtain this data from the retailers, from the third parties. So we get data with different quality. We get data with, some of them give all kind of data at a day level granularity. Some of them give maybe at a monthly level granularity and so on. Not just that. So just consider today, sales might be happening in a Walmart store today, and they'll get the entire data set by the end of the day. They have to process it tomorrow, and they have to send it to us by day after tomorrow. So the data we are getting is already delayed, right? So if there is a problem with the store, we are already looking at a data which is 2 days old. So how do we predict accurately that there is an issue with the shelf, and how do we resolve it ahead of time? So it's quite a challenging thing to do. Also, like I was saying, we are not a retailer. We can't just put a camera on the store and think that, hey, camera will generate an real-time alert when the shelf is empty. And we can't do it for all the retailers as well. We are talking about several retailers. Some of them are very small. We can't afford to put a camera there. It's not even, we don't own the retail store. At the same time, all the problems that with respect to privacy, camera and all other solution causes, right? And a lot of them have tried these solutions in the past. Some of them worked, some of them didn't work. Our solution is primarily from the data point of view. So how do we get this solved? So if you look at this image, let's say we take a shelf like that where ideally Listerine should be there. Listerine is one of our brand. And our goal is to turn the shelf into a filled shelf. So we work with brokers in order to make this happen. So we pay to these brokers. Brokers visit to the store. They make sure that they fill the shelf. They work with the store managers. They work with the store employees. They go to the back room and bring the product and put it on the shelf. So which means we obviously have to pay to these brokers in order to do that task, right? So whatever our algorithms actually predict that, hey, this particular item is empty. This particular item is missing in certain store in, let's say in US, maybe in Texas somewhere. So we have to accurately predict that the item is missing, and then we have to alert these brokers. They go to the store and they fix it, which obviously incurs cost, which means our benefit has to be better than that. Despite doing all of this, store employees may fix it by the time brokers visit there. So, it may happen that we may send an accurate alert, and what may end up happening is that store employees might already end up fixing it, right? And it's a natural thing to happen. And we want it to happen because we don't want to lose sales. All right. So, given that we are getting data from several retailers, it's not only the sales and inventory data that we are getting. We look at weather data, we look at several demographic data, we look at how frequently the items are replenished, what's the lead time for a product to reach to the store. We look at several such data that we receive from several retailers and third-party APIs. The problem here is everyone doesn't give it at the same quality. Everyone's schema is different. So we have to harmonize this data, bring to a common schema. We have to make it consistent. We have to make sure the data is of good quality, and then only we can use it for ML algorithms. So that's the first step in our process. So we have to harmonize it. And then, as I was saying earlier, some items are high velocity items, some items are low velocity items, some retailers sell with high frequency. In some stores, they sell 100 units a day. In another store, they sell 5 units a day, right? So we can't, if we have to so our goal is to generate an alert and send it to the broker that, hey, there is a problem in some store, in some shelf with respect to some particular item. In order to make this happen, we can't directly, so we need to forecast first. The reason to forecast is fundamentally because we need to get an understanding of what's the ideal demand, what's the actual demand that is there for these items, because we need to understand how much we are actually losing if we are not doing this right? So ideally, if there is, in an idealistic world, if everything is there correctly on the shelf, if weather is good, everything is good, ideally demand matches with the sales, but sometimes it doesn't happen. So in order to make an accurate demand forecast in the first place, we can't just build one model to fit for all the items. So we need to classify these items, store SKU combinations into different series, which allows us to forecast them more accurately. And then we actually have forecasting algorithms post the classification, which does the forecasting for, let's say, next 13 weeks or next 3 months and so on, right? Now, apportioning, like I was saying, some data we may get at monthly level, some data we may get at weekly level, but alerts we have to generate every day. We don't want to wait for 1 week to send an alert because we'll be losing sales for that 1 week, right? So we need to generate alerts. Sometimes we have to, we have to make the data more granular, like we have to make our forecasts more granular. We may have to convert weekly to daily and so on through the apportioning process. And alerts we can generate in many ways. As you can imagine, we can start with a simple rule-based alert, going all the way to advanced ML algorithms-based alerts. Now, we can do it, we can use different kind of alerts based on the need, based on the retailer, at what stage we are with the retailer, and so on. We also need to integrate our entire system, ultimately with the brokers. They will have their own system. Some of them might be using FTP, some of them might be using REST APIs, and so on, right? And so a broker gets a list by the beginning of the day. They go to the store, they will try to fix it. They work with the store managers and make sure everything is sorted. And they also send the responses back. So for example, if the broker says, hey, item is there on the shelf, why did you send me a wrong alert? So it could be a false alert that we have sent. Or the broker may say, we actually restocked it from the back room. We went back and actually brought the items into the store and actually filled the shelf. That's a positive alert for us, right? Now, we also need to calculate the value at the end of the day. It's not like we are just generating alerts. We need to figure out what's the dollar value that we are getting at the end of the day after doing all of this. So we measure with a lot of KPI metrics, which are quite important in order to make sure that every single alert we are generating is worth the value. Now, as I was mentioning earlier, we are going to break down these different store SKU combinations into different groups. We have coined here as gold, silver, bronze, but you can consider them as high velocity items which are frequently sold, at a, and high value items, they could be gold. Some of the items, they could be, they may sell 5 units a day, not so much, but they may sell like 5 days in a month. They could be bronze or silver, right? So basically the idea here is to group them in such a way which makes our life easier, which makes our forecasting, more accurate. I mean, if we think about a bit here, our focus is not to forecast it accurately. Our focus is to ensure that the product gets restocked on the shelf. That's the goal, right? We don't want to lose the sales. We want to make sure customer is happy. Now, but the accuracy in terms of forecast makes us better because we can correctly estimate the KPIs like lost sales, how much we are actually losing, how much we are actually recovering if we send the broker there, right? So in order to get those metrics accurately, it's important to make these forecasts accurately. So like I was saying, one model doesn't fit all in our case. Some of the data sets are quite intermittent, some of the series are quite sparse, some of them are very good data sets. So we can use variety of algorithms. Here we are using actually a factory of forecasting algorithms depending on the series. It may go through one of these algorithms, and whatever wins, the best one, the best algorithm that makes the more accurate forecast comes out. Now, so imagine we are onboarding a new retailer, let's say 100 stores. We don't have any data with respect to that retailer. Now, initially it makes sense to start, just sending, some rule-based alerts, right? So we take business experts, decision, like thought process in making out some rules so that we can actually collect some label data in the first place, let's say for a month. So we can start with rule-based alerts. Then we also, obviously if we have to make an ML algorithm and if prove that it is doing well, is it doing better than random, right? So obviously we can send random alerts as well. And there are some items which are at times strategically important. We have to send brokers so that they fix the shelves and the issue gets sorted out because they are high priority items. Let's say sunscreen, for example. It's summer going on. If we are not generating any alert for sunscreen, it doesn't matter if we send them in winter, right? So we have to make sure that we are sending the right alerts as well. So it's very important to have a configurable hybrid system, an alert fusion system in place which can accommodate all these things. Now, certainly once we have enough data set, we can build the machine learning model. That is what exactly we have done. We could build transfer learning models. We can build regular simple XGBoost models, right, GBM models, or any kind of classification model for that matter. As long as it does well, it generates the right alerts, we are good to go. Last but not the least, obviously calculation of recovered sales is quite important. As you can imagine, whether we are saving $1 million, what is the incremental sales that we are getting because of all these alerts? We are paying some money to brokers. Whatever we are recovering, is it better than that? Obviously, it has to be better than that, otherwise it wouldn't worth the bucks, right? Okay, so let's talk a little bit about what is phantom inventory. Now, phantom inventory is quite a hard problem. The reason is that, in data, we may see that inventory is 5 units, for example. But actually, if you go to the store, maybe there are 0 units there. Why? Because it could be due to shrinkage. Somebody might have probably stolen. Maybe it's a accounts issue. Maybe the products are there but are misplaced somewhere else, right? So there could be several issues. As long as there is a discrepancy between the system inventory and the actual inventory that is there in the store. Now, that situation we typically call it as a phantom inventory. Now, if you recall the OSA alerts I was talking about earlier, suppose imagine a scenario where we send an alert. Broker goes to the store. Broker sends a response saying that, hey, this item is out of stock, but our system says there are 10 units, right? And our products are also, take Neutrogena, for example, it's 1500 rupees. HydroBoost for probably is a small 100 gram, or maybe small HydroBoost is like 1500 rupees, right? We don't want to lose that sales. Now consider a big store, right? A store like Walmart is quite big in size. A store like Target is quite big in size. Now, we don't want this to happen frequently because store managers might be thinking the items are in stock, and when the customers actually come to purchase them, they are not in stock. Now, what happens is that typically when the item goes below the safety stock is a reasonable threshold of items that we maintain in the store so that we have enough items to sell even in the worst case scenario. An inventory management process gets triggered, an automatic purchase order gets placed, and we don't want this to happen so often because ideally if there is a phantom inventory, somebody has to put a manual order, or when they reset the inventory and if they correct the inventory, it puts an automatic order, which actually congests the entire supply chain process. They would be thinking that, hey, we have to send 15 items to the store in this month, but in reality now we have to send another 20 units, which ideally we should be sending for another store. Now, this is a very tough problem to solve because nobody is going to go to the store and actually count them, right? Store employees typically in US do they do audits in 6 months and 5 months and so on. They don't do it every day. And as you can imagine, the workforce in the stores might have less number of employees than typically what we see here in India store typically, right? Now, we can leverage the OSA alert responses that we got from the brokers, and we can actually use those responses as a starting point to train a phantom inventory classifier. Now, this is a problem which so many retailers are trying to solve, and it costs them a lot of money. Not only that, based on the patterns we typically identify from the data, we ourselves label some of the data points to have labeled data in the first place based on different patterns. For example, let's say there are 3 consecutive days where there are 0 sales, but I can see that in the inventory there are 10 items. Suddenly 10 items become 20 items and you suddenly see the sales, right? Now, this is a peculiar case. Ideally, it shouldn't happen. So why didn't the item sell for the last 3 days if there are 10 items? Is it just the case that the customers didn't purchase it? Or is it because new stock has arrived and whatever 10 stock which was there in the store was actually wrong, right? So we mark such patterns to create a label data, and we again build a classifier which is a phantom inventory classifier which again generates alerts. Now, we can send these alerts very similar to how we send these on-shelf availability alerts. They can brokers validate these alerts and tell us back, hey, these items are actually out of stock. And they actually end up correcting the inventory in the store. Okay, so if we look at the top chart, right? If you look at the last bar, which is the tallest bar, what it simply means is we are plotting here based on the probability score of the model. You can see clearly here, if we have the highest probability, we have 80% accurate alerts. So which means despite the 2 days delay, despite the inconsistent schemas that we get, despite the data quality, we can see that 80% of the time our alerts are right. Actually, brokers ended up correcting the shelves, right? They end up bringing from top stock, or they end up bringing from backroom and so on. Now, our goal is not to be just to be fully precise, as I was saying. Our goal is to make sure that these products are there on the shelf. So we have a long tail, as you can see. Even at 0.5 probability or 0.4 probability, you will find 10% of the alerts are right, 20% of the alerts are right. If 20% of these alerts are high dollar value items, we don't want to lose the sales of those items, right? Because some customers just purchase, let's say, Neutrogena HydroBoost, for example, once every 2 months. And if they don't find Neutrogena HydroBoost every 2 months, they may switch to a competitor product. We don't want that to happen. So the goal is to make sure that the items are still there, right? So we even send these alerts as well, because the benefit we get from that is more than the broker cost. Now, if you look at back in April when we started with rule-based alerts or random alerts, only 10% of alerts are right. This is for an actual retailer, one of the retailers. It may seem like typically we generally hear 90% numbers in accuracy, 80%, and I think these days 90% is also quite common, right? So only 10% of the alerts are right. So as you can see, with time, back in October, like couple of months, these results are a couple of months old. And if I combine this entire distribution, including the ones which has 20% accuracy, right? So 10% has gone to 60% or 55%. Now, in a real world scenario, in 15,000 stores, and we are rolling out for more stores. Next year, this would be 25,000 stores at plus. We will be expanding to other areas and so on. It's a pretty good number in the world of retailer, is what we are looking at. So just to conclude, idea is that we have an empty shelf somewhere. We looked at how we address this problem. How do we make sure that this item gets restocked, right? We saw an AI system that we have built, which is not just about AML algorithms as such, but it's also about the entire scalability of the system, which actually makes this system quite attractive to the entire retail world. Now, through the broker feedback that we receive, we continuously improve the system. As you have seen over the time, this is a right validation for us. Over the time, the models are doing quite well. They're actually developing every month or every week. Whenever we roll out a new version of the model, we can see high accuracy. And retail world is dynamic. And I mean, in India, we see now 5-minute delivery, 10-minute delivery, right? So it's changing. The landscape is changing so fast. We have to adapt. As part of the next steps, right? We are obviously tuning the system every day. Even today, also we are tuning the system to make sure that we are matching to the constant changes that are happening in the retail world. So as I was saying earlier, if somebody resets an inventory, it goes to supply chain processes and they have to order again. It's not like somebody has to procure materials to prepare them and they have to manufacture a product and they have to send all the way to the store. So it's a long process. So we are also in the process of integrating with broader supply chain systems, which makes this quite important. As I was saying earlier, phantom inventory is still a very big problem for all the retailers. And we are in the process of building much more advanced algorithms in order to solve the phantom inventory. So with that, thank you. I'm happy to take any questions.
Thank you, Sunil. I have a couple of questions.
Yeah, hi. Yeah. Just curious to understand, right? It's very dynamic, as you rightly said. So how often you rebuild your models in general? Like, is it on a weekly basis or monthly basis or as and when required?
Great question. So there are some forecasting models which we build once in a month, but we refit using those hyperparameters that we saved every week based on the latest week's data. Then there are some classification models which doesn't take that much time, which we retrain every week also.
Got you. Thank you.
So I had a couple of questions here on your left. Sorry. Could you just help me understand what interventions made that 5-10% accuracy at the beginning go up to 55%? Right. Was it just quality of data, or were there interventions at the behavioral level which helped you sort of improve this? And the second question was to understand if you go back to the previous slide once.
Which one?
Yeah, this one, where you had the phantom inventory classification model, right? So for forecasting, I would understand what would be the key factors that would help you predict. Right. What would be the key factors that you identified for this kind of a model? The key predictors that came out in the model
for the phantom inventory.
For the phantom.
Right. So one of the issue is definitely shrinkage in terms of, and it's not something we can capture also. But the problem with phantom inventories, there are a lot of features for which we actually don't have data. I mean, it's impossible to figure out when the shrinkage happened. We can figure out maybe through camera feeds and all, but it's a costly thing to do. So in the classifier that we have built, definitely the incorrect, there will be some returns happening sometimes. Probably people might have not recorded them well. There are items which are definitely stolen, which are not part of the model. Then there are items which are misplaced altogether. Like, let's say ideally it should be in the Neutrogena rack or Avino rack, but the item is thrown somewhere. In a large store, the item would have been thrown somewhere else, right? So we have the inventory in the stock. So inventory is there in our model as a feature. We have the shelf space. We can see that the regular transactions are happening, but suddenly we also see a on-hand correction happening for some reason, weirdly. Now all those instances, all such, like for example, on-hand correction happens for some reason, we actually derived variables on those and we actually included it as part of models. So a feature like on-hand correction, like an instance of on-hand correction, is a quite important one. Transit inventory ideally reaches to store, let's say in 3 days or 4 days or 5 days. If transit inventory reaches to a store, but you don't see the on-hand inventory, let's say if transit inventory is 5, on-hand inventory is 3, ideally it should be 8 if there are no POS sales, right? But we see in the data that doesn't happen all the time. There are some discrepancies like that. All such scenarios, all such derived variables that we created from the data ended up being important features for phantom inventory. Again, what I want to also say is that there are a lot of signals which we still have to identify in case of phantom inventory exclusively. And we are actually working on different solutions for this as well. We are working with retailers also to make sure that we get right signals, because ultimately we are talking about a retailer store. We are sitting on the manufacturer side. It's relatively easier for the retailer to capture those signals, but unfortunately we don't have all of them. Right? So we are still in the process of getting more signals, but inventory-based derived variables, sales-based derived variables, transit times, regular replenishment variables, lead times, they are all quite important in the model right now.
One thing, it's a time series model you are using now. You have past history of the demand and forecaster. Based on that, you can't extrapolate, and you can forecast now what are the supposed
right,
levels to be maintained.
Right.
Instead of doing on granular on weekly basis or daily basis,
right.
Your forecast will be there.
Yeah.
So maybe plus or minus you can keep it up, and as and when the demand rises, you will adjust it. But here your thing is you are looking at the retailer's perspective, and you are started forecasting.
Right, right. So the thing is, I can build a forecasting model. I assume that my forecasted model said 10 units I'll sell in the next week. But there is some issue, suddenly it rained that day, right? But in the data, we see 0 units sold on that day. Now my forecasting model has no way to pick it up unless I have other data in it. Similarly, let's say there is an issue on the factory side and we are unable to manufacture the product. Now that signal we have to incorporate in the model itself. Now when it comes to apportioning, which is increasing the granularity of the data. Now let's say certain retailer gives us once in a month. Let's say inventory, what we have is a monthly level data point. But the alert we need to generate is a daily level. We have to still, not every broker goes every day. Some brokers may go once in a week, some brokers may go once in a month. Now, depending on the time at which they are going, we may have to extrapolate, like you said. Ideally, we should be selling, let's say 10 units in a month. Let's say we already sold 5 units. We have to readjust the value in order to send the broker, if it is still worth sending it. So, apportioning still becomes important.
So certain cushion has to be maintained. Cushioning you have to take. Certain cushioning you have to give. Otherwise, exactly to the demand.
Absolutely.
That is very risky task.
Absolutely. Sir, actually, if you look at lost sales, ideally, if there are no lost sales, we would have the right demand. Like whatever we sell is the right demand. Whatever sales forecasting we do, plus the lost sales, is actually the right demand in general. Like there could be other things also. Now, whatever forecast we do for sales doesn't really indicate the full demand because there are some lost sales, right?
Losses,
so it's important to capture that lost sales also accurately.
And another one, so many models we have used.
Yeah.
LSTM is the forecast, and your invariant models you have taken, and Sarimax is also forecast.
Exogenous.
What
Right.
else? Other things are there. You have XGBoost and Elastic Net. There are straightforward forward models you have used. It is a stack of models.
Exactly, sir. So we need to transform the data in order to do forecasting for these models like XGBoost. Because
How it will sequentially it will go, or parallelly it will go to the models?
so all of them will actually predict
Uh-huh.
at the same time.
Okay.
Yeah, and not every item, every store goes to each of the model. After the series classification, some of these items and some of these goes into these models. Now, as you can see, like you said, right, univariate model, I can do a simple exponential,
Yes.
moving average or
Straightforward
something,
thing.
straightforward one. For a new series item, which we just launched, let's say 1 month back, we can do it for that. XGBoost, the advantage we get is instead of building one forecasting model for one SKU, one item, I can take 10 items and club them and still build a generic XGBoost model, even with some other models also, and we can still forecast for multiple items. So when we have sparse data, less data, right, we can build a zero inflated model or similar model using the XGBoost models and other models.
Okay.
I have
Thank you.
2 questions. The first is follow up to the discussion we were having. How do you maintain the exogenous variables, right? Like for example, you're using Sarimax.
Right.
Certain variables like, okay, holiday data doesn't change, but you're talking about daily alerts, and there is certain information that would change at daily level. So how do you manage that situation?
Yeah, so daily alerts is not applicable for every retailer. Some alerts might be weekly, some alerts might be monthly as well. Like you said, holiday information doesn't change. Christmas is always December 25th.
Yeah.
Now, some holidays, some events may change. Now, exogenous variables like inventory, for example, transit time, shelf space might be same, but if I change the shelf from one shelf to
Available
another,
shelf space. Okay.
yeah, so it may change as well. So there are some variables which changes. There are some variables which doesn't change. You can still encode some static variables into a different format.
But how would you get that data at that frequency? Do you get a daily or multiple times in a day streaming
So
data?
holiday
coming?
data and all are fixed for an year, pretty
Correct.
much. They don't change. But inventory sort of data, sales sort of data, we get every day.
Okay.
At the end of every day, we get the data.
Okay. And the second question is, how do you handle store openings? Because we're talking mostly about time
Yeah.
series. You need historic data. You need to set up certain systems
Right.
to get that started.
Right.
Yeah.
So when you say store opening, you mean the launch of the store, right?
Yes.
Yeah. So let's say if I take a time series, if I take one SKU and store combination, let's say the store opened 6 months ago, it may end up falling in. Let's say we don't have enough data for that store and SKU. We may end up actually building whatever national level model we might have built, we actually end up using for that particular store and item. We can, in the process of apportioning, like the server was asking earlier, we can actually change the granularity of the forecast that we did. Maybe we can extrapolate few of those things and then we can generate the alerts.
Got it. Thanks.
Yeah. Oh, I think we're out of. Okay, one last question.
Yeah. Have you also tried clustering these stores based on the attributes before jumping onto this forecasting and modeling thing?
Great question. Short answer is yes,
Yeah.
because this could be done in many ways, right? Not only clustering of stores themselves, we can even do clustering of store SKU items also. So yeah, short answer is yes, we did.
Yeah, thank you, Sunil. That was amazing. The session was
Thank you.
very insightful. Great round of applause, please. Yeah. Just one quick question. You said with quick commerce, this thing is changing. So, any insight there, learning in terms of how it is changing?
So right now we implemented in the stores of North America.
Okay.
We are yet to implement in the stores of India. But one thing I would say is our product available on some platform like Zepto when you're actually looking for it, or on Blinkit, right? So it's not a store space, but it is on the online page that you are seeing, or the app you are seeing, whether it is available or not. So that's also a shelf availability issue. Technically here, page space or a app space that we need to look for, and especially it has to come even in the top 5 items or 6 items.
Great.
Yeah.
Nice. Thank you, Sunil. That was
Thank you
wonderful.
all. Thank you
Yeah.
for being here despite almost 6 o'clock, I guess.
Yes.
Thank you all.
Yeah. Yeah. And thank you for the questions, guys. Amazing questions.